When modern structural engineers and thermal scientists first traveled to the desert city of Yazd in Iran, they were looking at a skyline that seemed trapped in time. Rising above the mud brick homes were massive, chimney-like structures known as Badgirs or Windcatchers. For decades, Western architecture textbooks treated these towers as beautiful cultural artifacts. But as global temperatures began to rise and modern air conditioning systems started consuming massive amounts of the world's electricity, scientists began to look at these ancient towers through a strictly analytical lens. Mechanical engineers brought in digital anemometers, thermal imaging cameras, and computational fluid dynamics software to find out if these primitive structures could actually compete with modern HVAC systems. What they discovered through rigorous physical testing completely blew them away, revealing a highly sophisticated understanding of aerodynamics and thermodynamics that was developed over 1,000 years ago without a single computer. The scientific investigation began by measuring how these towers interact with the fluid dynamics of wind. Researchers set up sensors at the top of the towers, which are split into multiple vertical chambers facing different directions. They discovered that the system operates on a beautiful application of pressure differentials, specifically Bernoulli's principle. When a breeze hits the windward side of the tower, it creates a high-pressure zone. This high pressure forces the fresh, moving air downward into the living spaces below. Simultaneously, on the leeward side, the side facing away from the wind, a low-pressure vacuum is created. This pressure drop actively sucks the stagnant, hot air out of the building. Scientists realize that the tower isn't just passively letting air blow through the house. It acts as a mechanical pump, continuously circulating air solely through the kinetic energy of the atmosphere. But the real breakthrough in the scientific study came when researchers looked beneath the surface. In the harshest parts of the desert, simply moving 45 degrees Celsius air into a house just makes the house hotter. Scientists tracked the airflow downward and discovered that the Persians had integrated these towers with qanats, extensive underground aqueducts carrying cold snowmelt from distant mountains. When the hot air forced down by the tower passes over this cold subterranean water, a rapid process of evaporative cooling takes place. The latent heat in the air is absorbed by the water as it evaporates, drastically dropping the air temperature by up to 15 degrees Celsius, while increasing the humidity to comfortable levels. Thermal cameras revealed that this natural, zero-emission process brought the indoor temperature down to a comfortable 22 degrees Celsius, creating a microclimate that defies the scorching desert outside. To fully understand the efficiency of this system, scientists began calculating the thermal mass of the materials used. The towers are built entirely from thick adobe, which is a mixture of mud, clay, and straw. Through laboratory testing, material scientists confirmed that adobe has a remarkably high volumetric heat capacity and low thermal conductivity. This means it acts as a thermal battery with a perfect time lag. During the blistering day, the thick walls absorb the intense solar radiation, preventing the heat from penetrating inside. By the time the heat finally works its way through the thick walls, it is already night, and the desert air has cooled down. The tower then sheds this stored heat back into the cold night sky, preparing itself to reset for the next day. When the engineering data was fully compiled, the scientific community came to a profound realization. These ancient builders weren't just guessing. They had mathematically optimized the height of the towers to capture the cleaner, faster winds found higher up, while avoiding the dust-laden winds near the ground. They had also calculated the exact surface area of the internal brick partitions to maximize the heat exchange between the air and the structure. Today, researchers in sustainable architecture are studying these exact aerodynamic properties to design modern, zero-energy skyscrapers. By uncovering the hidden mechanics of the Badgers, science has proven that the ultimate solution to our modern climate and energy crisis might not be more complex technology, but a smarter, more precise application of the laws of nature that our ancestors mastered centuries ago.